तो जब उसको पार्टिकल जैसे बिहेव करने के लिए बोला तो वी सेड दैट द पार्टिकल which makes a wave, those particles are known as photon. और उस फोटोन के उस वेव के पास एनर्जी तो होती है which was defined as E is to h nu, लेकिन उनके पास मोमेंटम भी होता है and the momentum is given by P is equal to h by lambda. and जो जो वेव के पार्टिकल नेचर को एस्टेब्लिश करता है that experiment is basically photo electric effect or photoelectric emission. Photoelectric emission. So we discussed about emission. कोई भी मेटल है, मेटल मतलब कंडक्टर होता है मेटल, उसमें क्या होता है, फ्री इलेक्ट्रॉन्स होते हैं. And these free electrons can be emitted from the metal by different process. So we discussed all this, क्या बोलते हैं, brief electron emission, thermionic emission, field emission, secondary emission, and photoelectric emission. The important point here was that the minimum energy required for electron emission, minimum energy required for electron emission from a given metal is defined as work function. Work function which is denoted by phi. और उस वर्क फंक्शन की जो यूनिट थी, instead of joules, it was defined in electron volt. And 1 electron volt is equal to 1.6 into 10 to the minus 19 joules. So work function is a minimum energy which is required. और minimum energy अगर required है, that means that electron will be lying on the surface of the metal. तो जो भी emission है, whether it's thermionic emission, that is you are heating it, whether it's a field emission कि हमने एक इलेक्ट्रिक फील्ड लगा लिया है जिसमें इस कंडक्टर को रख लिया, whether it's photoelectric effect जहाँ पे light is incident and the electron comes out, or whether it's secondary emission जहाँ पे इलेक्ट्रॉन या हाइड्रोजन आयन या हीलियम आयन कोई भी आके स्ट्राइक करता है और अंदर से इलेक्ट्रॉन को नॉकआउट कर लेता है. ओके, सो दीज आर डिफरेंट प्रोसेस जिसमें हमारे को इंटरेस्ट नहीं है, इट्स जस्ट एन इंट्रोडक्शन. तो यहाँ तक तो हम लोगों ने कल की क्लास में कर लिया था. सो एकम, दिस वाज एन इंट्रोडक्शन व्हिच वी ऑलरेडी डन यस्टरडे. मोस्ट बार बार वीडियो क्यों बंद कर लेता है?
सर वो डेटा खराब आ रहा है, क्लास से बाहर हो जा रहा हूँ.
बस ठीक है जब, तो फिर डेटा का प्रॉब्लम ठीक करो घर पे, बिकॉज आई डोंट वांट द क्लास टू बी लाइक दिस. ओके, सो हमारा इस क्लास में जो है ना, व्हाट वी हैव टू डू इज वी हैव टू अंडरस्टैंड व्हाट इज फोटोइलेक्ट्रिक इफेक्ट. ड्यूअल नेचर ऑफ रेडिएशन में जो एनसीईआरटी में मेजरली कवर किया गया है, दैट इज फोटोइलेक्ट्रिक इफेक्ट. सो फोटोइलेक्ट्रिक इफेक्ट तो बहुत सिंपल है, बट एनसीईआरटी बुक में क्या है कि डिफरेंट साइंटिस्ट के ऑब्जर्वेशंस दे रखे हैं. सो विल सी ऑल दोस जो एनसीईआरटी बुक में दे रखा है, उसको पूरा एक बार देख लेंगे हम लोग. Dual nature of radiation and matter. So some introduction is given and directly come to the photoelectric effect. So photoelectric सबसे पहले Hertz का observation. So what is the observation of the Hertz? Hertz observed that high voltage sparks across the detector loop were enhanced when emitter plate was illuminated by ultraviolet light from an arc lamp. So that was, he was doing some another experiment. He was not doing the photoelectric effect. He was doing some electromagnetic wave experiment. Okay. So there is a spark discharge, like you put a plate and then you apply some electric field or voltage, then the spark is produced. So some spark discharge experiment he was doing. So whatever was his detector loop across which he was applying the very high voltage, then he said that the spark which was getting ignited ना, तुम लोगों ने कभी स्पार्क देखा है क्या? जैसे हमारा क्या बोलते हैं, गाड़ी होती है ना, स्कूटर में भी एक स्पार्क प्लग होता है, उसमें भी जब हम किक लगाते हैं ना, देयर इज अ स्पार्क. तो इट्स आल्सो समथिंग लाइक दिस. अब वो जब गाड़ी चलाते तो लोगों को बहुत पता होता है. द स्पार्क प्लग इज समथिंग लाइक दिस, और यहाँ पे टिप होता है, एंड देयर इज अ कंडक्ट प्लेट हियर आल्सो. सो इसमें और उसके बीच में एक डिफरेंस होता है. एंड व्हेन द हाई वोल्टेज अप्लाइड बिटवीन दिस टू ना, तो इधर एक स्पार्क लगता है. ओके. So this is how the spark is ignited with the high voltage difference between the two conductors. So something like this he was doing when he was trying to produce the spark, and he said that whatever the detector loop in his experiment, that it's not given here. When the emitter plate was influenced by ultraviolet light from an arc lamp. So let's say this is the emitter plate. Okay. So this is some emitter plate, part of some experiment, and this is your detector. यू अंडरस्टैंड? तुम लोगों ने हर जगह ऐसा ही किया होगा ना, जब तुम अगर 11th क्लास में कोई कैथोड रे एक्सपेरिमेंट पढ़े हो या एनोड रे ट्यूब पढ़े हो या कुछ भी पढ़े हो, तो एक तो एमिटर प्लेट होती है, जैसे कुछ एमिट होता है, और एक डिटेक्टर प्लेट होती है जिसमें कुछ डिटेक्ट होता है. जैसे कि अल्फा पार्टिकल में भी यही था. अल्फा पार्टिकल एक्सपेरिमेंट में क्या होता है, थॉमसन के एक्सपेरिमेंट में, सॉरी रदरफोर्ड के एक्सपेरिमेंट में, यू एमिट अल्फा पार्टिकल्स, देन देयर इज अ गोल्ड फॉइल. फिर अल्फा पार्टिकल्स गोल्ड फॉइल को क्रॉस करके जाते हैं, और यहाँ पे पूरी एक डिटेक्टर लगा होता है. वो डिटेक्ट करता है कि अल्फा पार्टिकल किधर स्ट्राइक कर रहा है, इधर स्ट्राइक कर रहा है, इधर स्ट्राइक कर रहा है, इधर स्ट्राइक कर रहा है, या वापस रिबाउंड होके आया. सो सिमिलरली द एक्सपेरिमेंट विच हर्ट्स वाज डूइंग was simply a discharge experiment. And he said that when this emitter plate was radiated, like apart from applying the high voltage, when some ultraviolet rays were falling on it, uh, spark was enhanced when the emitter plate was illuminated by ultraviolet light from an arc lamp. So the conclusion was that that was facilitated because of the escape of the free charge particles. And the only free charge particles in the metals are electrons. Remember, proton is not a free charge particle. Proton is always bound to the atom inside the nucleus. The free charge particles in the metals are only electrons. At that time, when he was doing this experiment, electrons were not known. So it was only said that free charge particles. Okay. When the light falls on the metal surface, some electrons near the surface absorbs enough energy from the incident radiation. This enough energy, what we call it as, on the surface of the electron, which are the easiest to remove, the energy which is required to remove is known as work function. Okay. So in this case also, in the emitter plate, what are electrons are there on the surface? If this ultraviolet rays carries enough energy means more than the work function of that metal, then the electrons from this surface will absorb that energy, will overcome the attraction of the positive ions of the material of the surface, and after gaining sufficient energy from the incident light, the electrons escape from the surface of the metal into the surrounding space. That's all. So this experiment was not about the photoelectric effect. This was a side क्या बोलते byproduct of his experiment. He was doing some other experiment. He was only doing some electric discharge experiment of the electromagnetic waves. So he was trying to discharge electron by actually, like we can say, field emission, because he was applying high voltage between the emitter plate and the detector plate. But he said that that spark which was getting produced now, it was intensified whenever ultraviolet light was falling on this emitter plate. And at that time, he only said that the free charge on the surface of the metal came out. These free charge are later known as electrons. So this was the first experiment where it was studied that the electrons are emitted when the ultraviolet rays, that is electromagnetic waves, fall on a metal surface. Nothing more than that. Okay. Then there is another experiment which was done by Helmholtz and Lenards observation. Okay. So what we can say is that high voltage sparks across the detector loop were enhanced when the emitter plate was illuminated by ultraviolet light from an arc lamp. So he concluded after getting sufficient energy, the electron escaped from the surface of the metal. And what is this sufficient energy? The minimum sufficient energy is basically the work function of the metal. Okay. Now, this is one complete experiment which all Wax and Lenards did, and only the observations of these experiments are given, nothing else. So what is happening here is, this is a setup. There's an electrode, there's an anode, that is a cathode, there's an anode here. There's a photosensitive plate. This is a glass tube which is evacuated. And there's a source of light here and the quartz window here. And we have connected some battery and commutator and rheostat and everything here. Okay. So I will draw the simplified diagram here. So we have the cathode, we have the anode. This is a evacuated glass tube. And there is only a simple window here. And it's connected to the battery. That's all. Rest of all, I don't need right now. And I may apply the key here. Rest of all, we don't write here. So what happens is, if the light falls here, so there's a source here of the electromagnetic waves. Basically, we're talking about the light waves, but it can be any waves. It can be ultraviolet, it can be infrared, whatever. And then when this falls here, light falls here or electromagnetic wave falls here on the cathode, then the electrons are emitted. And this is evacuated tube, so that it's nearly vacuum inside, so that electron can easily travel. There is no collision of the electron with the air molecules or atom inside. So these electrons will travel here and strike this anode. So if then the circuit is completed, if the electron travels, then there's an emitter here in the circuit and it will detect the current. So this is a simpler setup. Okay. Now you see here that there is a commutator here. I'll explain you what is the purpose of this commutator later on. Then there's a rheostat to control the current, how much potential difference you have to apply, and the emitters you only to detect the current. That's all. Okay. So now what happens is, in this experiment, this source is of the electromagnetic waves. So they are using ultraviolet radiation. Okay. And this plate, which you are using as cathode, it is a photosensitive plate. Photosensitive plate. Okay. Then the electrons are emitted from the cathode and collected at the plate A, anode, by the electric field created by the battery. So when this battery is here now, so this will be like positive and this will be like negative. So this will be positive and this will be negative. So when the electrons are emitted from this plate, then these plates are attracted by the positive plate anode and they will travel in this direction. Okay. So they are attracted by this collector plate. Anode is known as the collector plate and cathode is known as the emitter. This plate we'll call it as emitter because electrons are emitted from here. And because you are collecting electrons here, so this will be known as a collector plate. Okay. The photoelectric current can be increased or decreased by varying the potential of the collector plate A with respect to the emitter plate C. So this we can by increase the if we increase the potential difference of this battery, then the electric field will increase. So the electron will be accelerated and more electron will move towards the anode. The more electron moves towards the anode, the more current is detected by this emitter. Okay. So this is an experimental setup. So what are the observations we can see in this book? What are the observations? Because I have not written the observations there. But there's a complete list of क्या बोलते हैं, experimental observation which is here. But let me first, so we'll do this again. But let me first see this, what Hallmarks and Lenards observations are. Okay. The first observation is first observation. When ultraviolet rays falls on the emitter plate, falls on, see, there are suitable condition, under the suitable condition, okay? When ultraviolet rays falls on emitter plate, emitter will detect current. Emitter actually will not, emitter detects current, okay? Emitter detects current. And when there is no rays, okay? And as soon as ultraviolet radiations are stopped, so when ultraviolet radiations are stopped, current becomes zero. Current becomes zero. Okay. That means what is happening is, so what does this observation indicate? This observation indicates when the ultraviolet rays falls on the emitter plate C, electrons are ejected from it and which are attracted to the positive collector plate by the electric field. Three things are important. First is the incidence of the ultraviolet rays, the emission of the electron from the cathode plate, then the electrons are attracted towards the collector plate anode because of the electric field. And when the electrons flows into the evacuated glass tube, resulting current flows. So actually what is happening here is, if you see here, this circuit is not complete. If you connect the battery across the resistance, the current will flow. So even if the current wants to flow in this circuit, the circuit is not complete because there is no connection here. So, but when the ultraviolet rays falls on this plate, when the electrons are emitted and the electrons reach this plate, when the electrons reach this plate, the circuit is complete. And then only the current starts flowing and the current is detected. When the ultraviolet rays stops, there is no current flowing. Okay. So this is one observation of this experiment. Ultraviolet radiation falls, emitter plates emits the electron. The electrons are attracted towards the anode because of the electric field. The circuit is completed and the current is flowing in the circuit. So it is basically the light falling on the emitter which is causing the external circuit to complete. Otherwise, the circuit was not complete. Okay, this is clear. So now what do we have? We have photocurrent, we have collector plate potential, we have the frequency and the incident of the incident radiation. So what all was studied with this experiment? The photocurrent. Why it is known as photocurrent? Because the circuit is only getting computed when these electromagnetic waves, ultraviolet rays are incident on it and the electrons are emitted, and we call this as photoelectrons. Then only the circuit is getting completed. Now this photocurrent, what does it depends upon? It depends upon the frequency of the light. The frequency of the light or the frequency of the electromagnetic wave. It depends upon the intensity of the electromagnetic wave. And collector plate potential. This plate, this anode, which is known as collector plate. Collector plate potential. If you vary the plate potential of the collector plate, how will the photocurrent vary? Clear? So this experiment was basically about photocurrent and what factors are affecting the photocurrent? The frequency of the incident wave, the intensity of the incident wave, and the potential of the collector plate, which is known as anode. So they also studied this experiment and they used this, what we call it as negatively charged zinc plate. So what did they do is this emitter plate, this emitter plate was replaced by negatively charged zinc plate. Okay. And with the help of the electroscope basically tells how much charge is there on the plate. And when the light was emitted on this, what they saw was that this negatively charged zinc plate lost its negative charge. Okay, this was also one experiment they did. When the negatively charged zinc plate, they were observing through electroscope, and whenever it was illuminated with ultraviolet light, that zinc plate lost its negative charge. And if it was further exposed to the ultraviolet light, what happened is that plate became positively charged. Okay. And the positive charge was further enhanced when it was illuminated by ultraviolet light. Okay. So apart from this, the another experiment which he did was, this is negatively charged zinc plate, and when ultraviolet light rays fall on it, what happens is it lost its negative charge, and after losing the negative charge, it became positively charged, and if it was further exposed to the ultraviolet light, the positive charge kept on increasing. Positive charge kept on increasing. So the only conclusion was, what was the conclusion? That negatively charged particles were emitted from the zinc plate under the action of the ultraviolet light. He concluded that the negatively charged particles were emitted from the zinc plate under the action of the ultraviolet light. So now, until now, we are only saying it's a negatively charged particle, Now, after 1897, when the electrons were discovered, these negatively charged particles were called as electron. It also observed that the emission of this electron was also related with the frequency of the incident light. Another observation from this experiment was emission of electron was related to the frequency of incident wave. When you increase the frequency of the incident wave, the electrons were coming with the more kinetic energy, higher kinetic energy. When you decrease the frequency of the incident radiation, the energy of the emitted electron was decreasing. But there was a limit, threshold frequency. If the frequency of the incident light was less than the threshold frequency, there was no emission of the electron. There was no emission of the electron. This was one observation. No electrons were emitted at all when the frequency of the incident light was smaller than a certain minimum value called the threshold frequency. And this minimum frequency depends upon the material of the emitter plate. So what was the observation? They use different emitter plates. Let's say they use a plate of zinc, copper, aluminum, different metals, okay? And they observe that for every metal, there was a threshold frequency specific to that material. If the frequency of the incident light was less than that frequency, the electrons were not emitted. And if the frequency was greater than this frequency, then only the electrons were emitted. Then this frequency was known as threshold frequency. It was found that certain metals like zinc, cadmium, magnesium, etc. responded only to ultraviolet light having short wavelength. Short wavelength means higher frequency. However, some alkali metals such as lithium, sodium, potassium, cesium, and rubidium were sensible even to visible light. All these photosensitive substances emit electrons when they are illuminated by light. And these emitted electrons after the discovery of electrons are known as photoelectrons, and this phenomenon is called photoelectric effect. Okay. So when it comes to the classification of metals, it says that elements like zinc, cadmium, and magnesium. What is the observation? Elements like zinc, cadmium, magnesium, electrons are only emitted by ultraviolet rays. What is ultraviolet rays? Short wavelength or high frequency. But if you say alkali elements like lithium, sodium, cesium, rubidium, lithium, sodium, potassium also, rubidium, potassium, rubidium. For these alkali metals, even for visible light has slightly smaller frequency. Visible light also, electrons were emitted. Okay. So then it depends upon the metal, which metal we are using. For few metals, you need very high frequency. And for alkali metals, even of the low frequency. Low frequency means large wavelength. Also, the electrons were emitted. So what is the effect of this frequency? Is what we will study in the detail. And that minimum frequency which is required for any metal. For this zinc, it will be, the minimum frequency will be this. For cadmium, it will be different. For magnesium, it will be different. For lithium, it will be different. For sodium, it will be different. For cesium, it will be different. All these minimum frequencies for particular metal is known as threshold frequency for that metal. So every metal has different threshold frequency. This is all what was observed in Helmholtz and Lenards experiment. Okay, these are their observation. Okay, is this clear to everyone?
Yes, sir.
Any doubt here? Any doubt here?
No, sir.
नहीं है. Ekam, are you following me what I am teaching?
Yes, sir.
Okay. So next is in detail study of the photoelectric effect. Experimental study of photoelectric effect. So now this is a detailed study. So what we'll do it is, we'll do it in tomorrow's class, the detail of the photoelectric effect. So even though 2-3 minutes are remaining, we'll stop the class here only today. Okay.